Operations. My name is Erik van Veenendaal. Next to me is Barry Schiffer, my colleague. And also joining with us today is Arun. And Arun is our head of Kubernetes, Java, and Web Technologies. So for today, our webinar will handle the deep dive for full stack Kubernetes observability with our solution, EG Enterprise. So a short agenda for today. We will begin with a short introduction of our solution called EG Enterprise. Then Arun will walk you through why it's important to have native Kubernetes monitoring and what's the difference between having EG as a solution or maybe a non-native Kubernetes monitoring solution. Then we will have about 25 minutes to perform a live demonstration of our solution where we will demonstrate various features of our full stack observability solution. And at the end, we will give some instructions on how you could maybe test drive the solution. And we also have some time for questions. So there's a questions tab. You should see it. So if you have any questions, just raise them in the chat, and then we'll try to answer them at the end of the session. So with that, I'll hand over to Barry to give a short introduction of EG Enterprise.
Yes, thank you, Erik. Yeah, so before we start and handing it over to Arun, let's first do a short introduction of our solution, EG Enterprise. So our focus has always been answering the most important question: why is my application slow, or why is my application failing? We do this for a multitude of IT services, from desktop monitoring to server monitoring, and of course, what we're going to talk about today, application monitoring on Kubernetes infrastructure. To make sure that we can really answer that question, like why is my application slow, we have built within our solution domain expertise for more than 650 technologies. So that means that we have built at the level of where a point solution would be for each of those technologies, but then from one single pane of glass within one solution. And the problem we're solving with the solution is answering that question, like where is the issue really starting, ideally proactively, but at least when it's reactively and the issue is already there, of course, as fast as possible. And with the observability solution and end-to-end monitoring, combined with the domain expertise we have built into the solution, we can really answer that problem. And where is that root cause of the issue? So, and with that, I'll hand it over to Arun for the next part of the webinar.
Thank you, Barry. And I think you have framed the problem statement, which is the fact that the problem still exists. The problem statement is the same as to why applications are slow. It so happens that Kubernetes severely complicates the problem. So if you switch to the next slide, we'll talk about the fact that Kubernetes applications are inherently very dynamic. So as you know, Kubernetes has pods. Pods contain containers, and containers run applications. And when a pod dies, let's say at 3:17 a.m. in the morning, by the time you log in, it's gone. And traditional monitoring tools fail in this regard because traditional monitoring tools always expect a static IP into which you can SSH into, and that's simply not possible in Kubernetes. So you need container monitoring and orchestration monitoring that is continuously checking for new pods that are created and destroyed, right? And that's the reason why you need Kubernetes native solutions, monitoring tools. The second part is not only is the IP addresses and there's a constant churn of pods, there is also dependencies. So typically teams organize themselves according to microservices. And these microservices have dependencies with one another. And for example, if the payment systems microservice fails or if the payment gateway fails, you have a cascading effect. That's true even even in bare metal or on premises or your traditional services. But when you mix the fact that, for example, a liveness probe fails or a readiness probe fails, and a pod gets restarted, it will take some time for the upstream pods to recover from that issue. So there is this concept of cascading chaos that happens in Kubernetes. Thirdly, there is the constant rescheduling, there's the cascading effect, but also consider the fact that you might have 20 microservices with dependencies across each other, and you will actually get 20 into n number of alerts because each service has its own operating system, it has its host, it has its processes. It could have Java, it could have .NET, it could have Node.js, it could have PHP, and so forth. And what you have is the core issue could be the fact that the payment gateway is down, but you could have hundreds of alerts confusing your team and flooding your team, right? So the net effect of all this is the fact that you have utter chaos, and you to cut through that chaos, traditional tools are not enough. You need Kubernetes native monitoring tools. So next slide, we'll look at what is the impact of this. And if you look at the impact, it's beyond uh, it's beyond just the monitoring complexity. It's also cost, because ultimately IT serves business, and that chaos, which I talked about previously, costs the business. And so your leadership team may not be really perceptive of, or they may not care about pod failures or pod restarts, but what they care about is that downtime. And if you are not proactive with your monitoring tools, if you're still stuck on the traditional monitoring tools, it's going to cost your business, quite literally. So there is this concept of a Netflix case study, and Netflix reported that their engineers spent more time debugging the monitoring tool themselves rather than debugging the actual problems. And that happens because the traditional monitoring tools become part of the problem statement, not the solution, right? So you need the native Kubernetes monitoring. That's the takeaway. Otherwise, there's a cost impact. So I think let's move on to the next part of it, which is we've looked at the chaos because of dynamic pod restarts. We've looked at the dependencies. We looked at noisy alerts, and therefore there's a cost to the business. And typically, what happens is IT teams might rush and say there is a dashboard for that. There used to be a saying called there's an app for that, and these days I think there's a malaise that in the IT teams where they say there's a dashboard for that. So a CPU dashboard, a memory dashboard, a host dashboard, a network egress ingress dashboard, and the list goes on. A JVM dashboard perhaps for your Java monitor, for your Java applications. And the myth is that the more dashboards you have the more visibility you get, and that's simply not true. In fact, the opposite is true. The more dashboards you have uh, during an incident, you are switching tabs across all these dashboards. So while you might have amazing open source solutions which have powerful graphing abilities or dashboarding abilities, that dashboard is just an enabler uh, for the context that's stitched automatically. Dashboards don't stitch context. The tools that gather in the logs, metrics, traces, and events, as we'll look into in this demo, those stitch the context, and then the context is surfaced in dashboards. So I think the key takeaway is Dashboards themselves are not the answer. In fact, you're going to swivel chair between dashboards, and it's about conflicting data as well. So you might still have a database administrator, a sysops, a DevOps, an SRE, and an app developer all having their own dashboards, and you still don't know what the truth is, and you'll still continue to call for an all hands war room at 2 a.m. at night. That's not helping. So what is the answer? So let's look at what entails native Kubernetes observability. So I told you, we were talking about the fact that pods come and go. So the first thing is a native Kubernetes monitoring tool needs to be touch-free, automatic, and auto discovery enabled, which means with zero configuration. And you'll see in EG supports EG operator, a Red Hat certified Kubernetes operator that's touch-free, and it automatically instruments your underlying apps within containers, the pods themselves, the containers, and the underlying host infrastructure, the node and the host infrastructure. And you need the ability to map them and visualize their dependencies without any manual setup. Because imagine a new pod coming in at 2 a.m. If you need visibility, it's going to take a lot of effort to get up at 2 a.m., change configuration settings, and by the time that happens, that pod has probably vanished, like we talked about earlier. So you need zero configuration discovery. Secondly, you need that real-time mapping. And we'll see in the demo how EG maps, for example, the control plane dependencies. And given the dynamic nature of Kubernetes, it's really important to have that live mapping of dependencies. And that takes us to a concept of a single pane of glass. Although it's been a much derided concept, you really need a single pane of glass that brings in the logs, metrics, traces, and events. And Kubernetes is a highly event-driven system. So you need the events. Next, you need the ability to scale that monitoring, because as Kubernetes, you don't need to add any more pods or nodes, but even within your current setup, because of the dynamic nature and the auto discovery part, you will have pods that come and go. New pods may get added, new nodes may get added or removed, pods may get shuffled between nodes, and you need the ability to scale this explosion of data, right? A few final points are the fact that, remember I told about the fact that there are a lot of dependencies. You need that automated root cause analysis and the alerting that goes with it to say that when let's say something failed in Kubernetes, why did it fail? It failed because of the operating system anomaly, a process, the network, the JVM, the container, or the application code that's running within the container. So you really do need full stack native Kubernetes ability. And lastly, you need that you need to do that at scale, which I talked about, but also you need that low overhead. And for example, in EG, we set limits to each of our own agents so that we consume only a certain CPU and memory. And we'll see that in the coming demo. But essentially, it has to scale, and the Kubernetes agent itself should be pretty lightweight. It shouldn't cause overhead. Lastly, you also need to connect to the business. So the mapping of the Kubernetes health back to your business transactions and the end user experience, which you'll see in this demo, which I'm sure Barry will talk about, is really important. Now, when you talk about a single pane of glass, that's pretty much it. You're seeing an example there on the slide that connects all the dots. You see a topology, you see a Kubernetes, you see logs, the business funnel, and a real user monitoring aspect of it. There's a business transaction monitoring aspect of it. Logs and events are really important in Kubernetes, and connecting them back to the tying that to the metadata, to the namespace, the pod, the daemon set, the stateful set, the replica set, or the deployment is really important. And so now we have talked about the fact that you need native Kubernetes observability, and the fact that you need deep diagnostics is really important. So let's talk about that a bit, right? Why does EJ Enterprise go deeper than other tools? We talked about the fact that Kubernetes is a highly event-driven system. So what you see is just the tip of the iceberg. So you see the symptoms, not the root cause. And you need to know why something broke and who it's affecting, right? So it could be the fact that, like in my previous example, the payments team, they need to investigate the root cause, not necessarily the front-end team or the products team or the shopping cart team, and taking an e-commerce example. So simply reporting on symptoms such as CPU is high is simply not good enough. That's what traditional monitoring tools do. But you could have issues with the Kubernetes layer where you could have pod scheduling issues. You could have a problem with the image not getting pulled. You could have a problem with the persistent volume at the storage level. You could have a problem with the actual cloud vendor itself. For example, it could be either of AWS or Azure, who could have an underlying problem. And you need unified observability across all of these, as well as your on-premises Kubernetes, which often talk to your cloud Kubernetes, visualize them on a single console. I already talked about the fact that you need to connect the dots between your Kubernetes experience and the business transactions and the end user impact. And lastly, you need that role-based access, right? Because you have a widespread team. Not everybody needs to know all the information. It has to be on a need-to-know basis. So that role-based access control is important. If you're an MSP, or even if you're a shared services organization hosting many teams, many sub-organizations within your organization, you need that multi-tenant support. You need the right tagging and metadata, for example, namespaces and deployments, so that you can do targeted instrumentation, which we'll talk about later. And so these are some often ignored capabilities when people look at open source stacks. Open source gives you tremendous flexibility. They might give you rich dashboarding, but ultimately, as your organization grows, you need these kind of capabilities. So that's a quick summary of what you need in a Kubernetes native monitoring solution. I'll let Eric and Barry take over from here.
Thank you, Arun. And let's go to one of the dashboards to start with. So just clicking this one and this one. So Arun just shared some of the dashboards where we can visualize data together for one component or for multiple components at once. And this is one of those dashboards that you can create yourself, customize, and present maybe on large screens in certain rooms of the IT department, or just pick up these kind of dashboards when you want to investigate something. So this dashboard could, for example, be for a product owner where we will visualize multiple parts of the environment. So not only the Kubernetes environment, but also maybe the application layer and the infrastructure layer. So on top, we see an overview of the Kubernetes health with certain things that you might want to visualize, like were there nodes or pods not ready or available over the last 6 hours? Are there actively unhealthy containers, things like that? But we can also visualize the user experience and the overall application health. So is the application available, and can we even see content in the application? Like over here, we show the user experience score, but we can also visualize if the page load time is increasing, if the page views are also increasing, or if if the environment is basically stable, of course, and able to handle the load. We also show top 10 transactions, so which transactions are slow for the users. And we can also make sure that you are aware of the underlying infrastructure components that basically are needed to run the application and the Kubernetes infrastructure. So if I switch now to another dashboard, then you can see that this is purely focused on all kinds of metrics that are important for maybe the SRE that's responsible for managing the Kubernetes environment, with all kinds of information on cluster health, performance, things like that. This is interactive, so I can click on one of the measurements and then go deeper into the visuals that we have, see more data, maybe connect the dots, things like that. But to give you a perspective, you can just add widgets yourself. So it's really a no-code My Dashboard solution. So you don't need to write any code. It's just adding the widget that you want to have, using the visualization that you like, and then clicking the right metrics in there. So at the moment, as Arun mentioned, I'm logged in with a user account that has a read-only role. So I cannot change anything, and I only see information that's assigned to this user. And I'm already logged in, and we see two tabs. So we have the Monitor tab, and we have the Reporter tab. So in the Monitor tab, you could say that all active metric data is there. We have all kinds of dashboards. We have out-of-the-box dashboards, but we also, like over here, that we'll handle in a bit. And we also have the ability to create your own dashboards, just as I explained. In the Reporter tab, you will find all kinds of out-of-the-box reports that we'll handle in a bit, where you can exactly specify the timeline for which you want to see the data in the report. Now, maybe a few words on how you enable the monitoring of your Kubernetes environment with EG Enterprise. So in the first place, you could start with a wizard-based approach where there are multiple options. So there's flexibility in how you want to enable the monitoring and on what fine-grained level. So there's an option to go with a holistic end-to-end approach where we use a Kubernetes operator, where we will automatically find all new nodes, for example, but also if nodes are not available anymore in the cluster, then we'll automatically clean those things up. So the dashboards and the information that you're looking at is really up to date and meaningful. There's also an approach where there's more a selective approach, more controls, where we use daemon sets. For both situations, we use, or you could use Helm or auto-created YAML files to basically enable the monitoring. And we also have options to monitor the containerized applications. We can do so using auto-instrumentation or auto-configuration. So once applications pop up, that they are automatically found and monitored by EG. Now that the monitoring is in place, we will automatically find issues basically in the environment. So how that works is that by default, we have all kinds of out-of-the-box thresholds in the product based on the technologies that you monitor, based on industry standards, based on feedback from customers. So once you start monitoring and see issues like you see here in the middle column, then you don't need to set thresholds yourself. These are all built in, so it's really a fast setup and less maintenance basically to work with EG. As you can see on the left, there are different priorities that thresholds can have. So a red colored threshold or alarm is of course the highest priority, and a yellow one the lowest. All these kinds of preset thresholds can be adjusted, can be fine-tuned according to your needs and according to the environment that you are operating. Now, as you can see also, we support basically multiple vendors of Kubernetes. So it's a multi-vendor overview directly. If I didn't have permissions, for example, for Red Hat OpenShift, then I wouldn't see the open alarm over here, of course. Now in the middle, you can immediately see what kind of alarms there are active. You could also choose to filter on the priority or maybe on the technology. You can also search for certain alarms that are there, of course. But what the beauty basically is that it's really a single view, a single console for all your alarms. So it's for metrics, it's for events, it's for logs, and it's for traces. And it will immediately provide information about the root cause. So if I click on this magnifying glass, then we'll have a pop-out window, which I'll make a bit bigger. And then immediately you can see that for this alarm, we can spot like, okay, this is the namespace, this is the pod name, and this is the node name. So this will help you determine which team is responsible for solving this issue. So who is the owner, basically. Now, if I scroll a bit to the right, then you can also see, of course, the container name and the start time of this problem. And you don't have to search log files yourself or run certain kubectl commands, because we have the error message directly presented in the console. So this really saves a lot of time in doing troubleshooting, things like that. And you could also say that you will maybe have to be less familiar with all the technologies. So there's one more option that we can help with that. So we have an AI assistant built in the product, and that can help, of course, staff that's maybe less skilled also get a sense of what's going on, because we will explain like the issue that we are looking at. It can tell you what the impact on the environment could be. You can do a anomaly detection and a root cause diagnostics, where we will tell you, okay, these are the possible causes, and these might be the next steps to basically resolve the issue. So if I close this. Now, if I click on this alarm about the failed readiness probes, then I will be directly brought in the console to a deeper level of where the issue is. So you can also look at other metrics. I will first start with the building dashboards that are there. So these are dashboards you don't have to build or maintain yourself. We do that, and once you start monitoring a Kubernetes cluster, these will automatically pop up and be brought alive. So again, this is a multi-cluster overview. So we can see Red Hat OpenShift, a vanilla Kubernetes environment, and also a Rancher environment. This gives basically a high-level overview of like the number of namespaces, the number of nodes, with also a split between the master and the worker nodes. Of course, the same for the pods, how many containers are actively running, and information about like high-level resource consumption in the cluster. And again, if you would want to, also over here, you could see which active alarms are there for the cluster. If I click on one of these links, basically, I'll be again brought in the console as it's an interactive approach. But I'll switch to the nodes first, where we can basically show all nodes that are in the environment. These are master nodes. I can also switch to worker nodes, of course, where you can see at which cluster the node is part of, if the node in this case is healthy, and on the right also like the resource utilization of the node itself. I can also click on one of the nodes and get a different visualization where you can see that we understand the architecture and the different roles that basically live in a master node. So if there's an issue, we can also do a correlation based on this as we understand the dependencies. You can see that we also have information about the node IP, the name, the kubelet version, and again, a bit more details about the resource consumption. And once we dive deeper, you will see that we have far more details about that consumption. Now, if I go back, then we also, of course, monitor all the containers that are active in the environment. If there would be issues with one of the containers, then they would not have a green color, but one of the other colors with a threshold on it. And what we also automatically do in the console, that's for the clusters and for the nodes and for the containers and for other things, is that we basically sort based on ratings. So if there would be a container with an issue, it will be on top immediately. Now I can also search and filter, of course, but so maybe I want to know If there are a lot of container restarts, then I can just simply sort on that, of course. Now, we also support containerized applications and the monitoring of the containers within the container, applications within the container. I will handle that in a bit. So we will first more zoom in to all the details. Now, as you can see, and you will see this also for the master node and other components that we monitor, is that we have a layered approach, to call it that. And this helps at first glance, I would say, in how to visually interpret things, because you can immediately see, okay, these kind of measurements are connected to a certain layer, and that gives a sense of where in the environment issues are happening maybe. And it's also within the product that we can use those layers to automatically do a better correlation, of course. So if I start on the top, in this case for the Kubernetes cluster, then we monitor all Kubernetes services. And what we automatically do is that we group them based on the namespace. So you don't have to manually do this. Once there are new services or namespaces, these will automatically pop up, of course. And for the namespaces, we have all different kinds of information. So throughout the console, if you see a magnifying glass, then you can click on it to get more details. In this case, it will tell you what the cluster IP is, what the internal and external endpoints are, things like that. We can also see which pods are active over here. So that gives a sense of the node name that the pod is running on, what the pod IP is, things like that. And if we now switch to one of the other layers, we also see alarms over there. It's the Kube workloads layer. Now, over here, you can see a lot more specifically built tests to do basically health checks and metric collections of all different kinds of the Kubernetes cluster. A lot of the components already mentioned also by Arun. I will just handle two for now, as we are a bit time constrained. So over here, you can see that we monitor the Kubernetes pods. And again, we sort them and list them based on the namespace. Now, if I click on one of the pods in the database namespace, then again, you can see that there's a lot of information. Information about how long it's already running, which type of image, things like that. But also if that pod is healthy or not, and also if the pod is within the resource allocation and things like that. So how much CPU is used, how much memory is used, things like that. Now what you could do is maybe think, okay, but we saw a lot of container restarts and I want to see if there's a certain pattern or get a sense of that. That can be done using the reporter or using widgets in dashboards, but it can also be done over here. So if we look at maybe the total container restarts within the whole cluster, then I can just click on a graph icon, choose maybe a longer timeline, and then exactly see at what time how many container restarts there were in total, and also of course, if there are certain pods that pop out with container restarts. So handle one of the other tests that we have for the Kubernetes deployments, again, by namespace, with details that you can look up, of course. If I scroll down to the bottom, you can see one of the events that's going on. So we see that there are out-of-memory events. And again, we can simply click on the magnifying glass and see that we have a container continuously trying to restart, but that fails. We can see immediately also what the error code is over here and all kinds of details about the container name that you can see. So I talked about the thresholds a bit. You can always find active thresholds if you click on the eye. So if I would have permissions to edit them, then I could also tune thresholds over here. And as you can see, these are all thresholds that have a fixed value. We also support auto-created and auto-baselined thresholds. With that, we will automatically calculate a different threshold for each hour of the day. You can choose one of the both or apply both to certain components. And also important to mention, I think, is that we have a offline help file. So for every test that we have, for every measurement that we have, we explain basically what it means, how you should interpret it. So this can again help you troubleshoot issues, especially if you have maybe less skilled staff. So you can see that we also have other layers. So for the Cube cluster, where we monitor all the nodes that are there, again, with information about the health and the resources that are being used. And also the Cube control plane with basically all the events that can happen. So a lot of different events, and automatically we have set the thresholds and will alarm you when there are issues. You can see that we monitor the Cube API server connectivity. So this will contain the latency and the availability. We also have the garbage collector. So a lot of things based on the Kubernetes cluster. Now it could, of course, also be that you have certain application teams that you want to provide access and provide details about their namespace. That's also possible. So then we have a specialized view that will only provide the cluster details, but then specifically to the Kubernetes namespaces that you can then set and apply to users. So let me quickly check. Let's switch to, in this case, a master node. So again, you see that we have a layered approach with a lot of information in there. This is a virtual machine, so we don't see a hardware layer, but otherwise it would be there, of course. And from the bottom up this time, you can see that in the operating system layer, we have a lot of details about like what's going on from the disk activity, from the inodes, from the processor, from the memory usage, and again, with all kinds of details. So you could, for example, use a graph and maybe set it a bit longer. Maybe you see a certain time period where you are curious, okay, what happened, which a process or a container used a lot of memory. Then you can simply drag and click, and you get all the details about the active memory at that point in time. This will work the same for the CPU, of course. So we have information about the network, information about the health of the different Kubernetes services within the master node that we also use to visualize the dashboards that you just saw. So information about the APIs, API server, etcd. So all built-in tests. You don't need to configure these yourself. It will populate automatically once you start monitoring the Kubernetes master. So switching to a Kubernetes worker, so you can see it's the same approach, but a bit less layers because it contains not the control plane, basically. And you can see on top that we have the same layers for containers and for pods. Now, if I click on one of the containers, you can see again that we track all the resources that are being used, also the bandwidth that's being used, if there are certain events happening, things like that. And again, a magnifying glass where you can get information about, okay, but which process in the container is then actively using a lot of CPU, for example. The same for the pods, but then an overview, of course, of which containers in the pod use a certain amount of CPU. So I mentioned before that we also monitor the containerized applications. So I need to switch to this environment. And if I now click on that out-of-the-box dashboard, then you can see that there are a few containers being monitored in our environment. These containers are auto-discovered. So once containers are running, we can do an auto-discovery. We can determine which kind of technology is being used. We can use auto-instrumentation and auto-configuration to basically set the right configuration so that we can monitor, for example, the MySQL database, but also that we can look inside what's happening in an application server like a Java application. So now just clicking on that Java application, you can see that we really understand the application that is being used. So we show if the application itself is healthy. We can also monitor the log files. So if there are certain issues within the application or in the container, then we can automatically find those issues and present them to you. And as I mentioned, using auto instrumentation, we can also track basically the transactions of the user. And with that, I will hand over to Barry.
Yeah. So now Eric has obviously explained infrastructure monitoring and Kubernetes monitoring from an infrastructure perspective. Obviously, in observability or end-to-end monitoring, we need to know more than just what's happening within the infrastructure, but we also need to know what is the health of the application running on the system. So within EG, we've pretty much supported APM, application performance monitoring, for many years, and now also we have included the same functionality on top of Kubernetes, of course. To start with the first functionality, real user monitoring. That gives us insights into how well is the application performing from a browser perspective. So on the endpoint of the end user accessing the application. So in this case, we have the Pet Clinic application, which is running on our Kubernetes infrastructure. And we can see that there are users connecting to this application. Now it's only users on desktops, but if users are accessing the application from a mobile, we would see the difference between mobile and desktop as well. We can see the request time, the server time, and the content download time. And we can also see this based on geography of the user. So maybe there are users accessing the application from Europe and the performance is really good, but users accessing the application from the US have a bad performance. So we can differentiate based on the data we get from the end users. We can also see the live sessions for this Pet Clinic application. And we can see those sessions. These are all Windows devices, but also for Mac and iPhone, you would see the difference. And when we click on this, we can actually see like the session and the chart view of how a user acts within the application. And for this session specifically, we can see the start icon here. We can actually do a session replay, so we can see on the screen exactly what the user was seeing on his endpoint. So really helpful functionality to get a really good feeling about how well is this application performing from a user's perspective. Of course, transaction monitoring, as was just shown by Eric, plays another role in this, where we can actually see what's happening on the web server running on the Kubernetes environment. So if we have the Java, Apache, or Tomcat web server, we auto instrument it for transaction monitoring, and then we can see the actual transactions within that application. So where we were just seeing the transaction from a browser perspective, we now see it from the web server perspective, where we can actually see, okay, what's happening on the backend and why is a certain application slow or why is it giving an error. So in this regard, we can see that from the web server calls over HTTP from some external REST API or HTTP call, and that's taking 13 seconds. So that's delaying the application. And what's really powerful in EG is when we combine it, we can actually see it end to end. So we can see the same transaction from the browser perspective as well as from the web server perspective. So you really get that end-to-end view of why is that application slow. What we see here as well is that we have, aside from the out-of-the-box dashboards that we deliver for all of the components that we support, we also deliver a lot of out-of-the-box reports for containers, Kubernetes, virtualization. Pretty much all of the components that we support, we have already built in the required reports So you don't have to spend a lot of time on creating those dashboards and reports. And you can just start working with the information that's coming from EG out of the box. So here we also have an overview report, but also on the real user monitoring side, there's an out-of-the-box assessment report where you can just see what's the performance of the application from more like a business report or a product owner report. So this really is the result of everything we do to host that application. So aside from like the real user monitoring and the transaction monitoring, we also have synthetic monitoring, which is really helpful, where we can simulate a user accessing the application. So in this case, again, it's the pet clinic application, and we have recorded a script that our engine is automatically running and browsing through the website. So we have a couple of transactions defined where we simulate a user clicking through that application, and we measure if the step is successful. So we can check this based on content validation or maybe image validation. And then we also baseline automatically the time taken to load that web page. So whenever something happens and there's an increase in load time, we will automatically send an alert. And when the application fails or the transaction fails or is successful, we can even take a screenshot so you can immediately see the result and what kind of error there was on the within that application. This is a fully no-code solution, so you don't have to write your own scripts or you don't have to write JavaScript code. It's a GUI-based recorder that just records the step that an application admin is performing within the application, and then we can optimize and replay it. But again, without any coding, so it's only wizard-driven configuration. So it's really easy. And a typical website script we can deliver in pretty much 2-3 hours, and then it's fully up and running. So now that we have shown all of the functionality that we have in place for infrastructure monitoring, Kubernetes, but also the virtualization, network, storage systems that are beneath it, included with the real user monitoring, the transaction monitoring, and the simulations, we can combine it into what we call an end-to-end topology. So this is native EG functionality, where from the user performance all the way up to the lowest infrastructure component in the environment is combined in one end-to-end view. And once we have that in place, we have auto discovery for this, but you can manually optimize it. And the dependencies between the components are in place. E.g., root cause analysis engine really starts to shine, where you can see that some alerts will be reduced in alert level. So we always try to pinpoint that main issue in the environment. So the biggest issue in the environment is highlighted in red. We can simply click on this icon and see what's happening there, drill down. Eric has already shown some examples of this. And when we click on this, we can instantly start the AI assistant explaining us what's happening in the environment and give you some ideas about how to solve it or which team to direct a ticket to actually solve that issue. Then there's one last report that I want to highlight, and that's the operational report, alert resolution. Again, this is all out of the box, so you don't have to do anything to get those reports aside from setting up the monitoring of components. And with this report for the entire end-to-end service, we get an overview of how many alerts were there in the last day, how many alerts are still open, the differentiation in critical, major, and minor alerts. And we can also see an alert trend that for the timeline we give, so now it's 1 day, but you can also set it to 1 month or 1 week or a year. You can actually see, is there a trend in issues? So what's the trend in the number of alerts or the time spent on alerts? So you can actually see, are we improving stability or is it decreasing? So that's my part of the demo. So we can switch back to the presentation. And
we've shown a lot of things, I think, in a short period. So of course, we hope that you found that interesting, got more curious about what could help you. So yeah, no matter if you think like one of the auto discovery features or maybe the correlation that we provide, if you want to know more about it, then of course you can test drive it yourself using a trial or using a proof of concept. So I think good to mention is that our solution can run fully on premises and fully air gapped. We know it's important for certain organizations and know that we can fully support that. We also have a SaaS environment. In fact, we have multiple regions. In this case, you could register for a trial on the SaaS platform on emea.eginnovations.com. If you want to use a different region, then just reach out to us. In the next slide, you will find our contact details. Of course, you can also use the website or register anyway, and then we'll be in contact. So registering only takes 2 minutes of your time to register, basically, of course, and then you will get 1 month of free licenses to run a small Kubernetes environment. Once you've done the registration, we'll make sure that we'll get in contact with you to share some quick start guides, and then really within the hour you can get up and running with full stack Kubernetes observability. And with that, let's look at the questions that came in. And as you can see, our contact details are here. So if you have a question, that just reach out to one of us, and then we'll make sure that we can follow up.
Yeah. So first question for Eric: does your tool cover all flavors of Kubernetes?
Yes. So we already saw a few during the demo, and you could say that we can support any kind of Kubernetes flavor as long as it's based on the CNCF standards, of course. And as you saw in the demo, we have also specific support for various flavors like AWS EKS, for our Azure Kubernetes service. We saw Rancher, we saw OpenShift. We also support the VMware vSphere Kubernetes service. So really different flavors, no matter if it's running on-prem or in the cloud. Yeah.
And then we have a question for Arun. Does your tool correlate liveness probe failures with metrics like CPU saturation?
Yes. In fact, you would have seen Eric demonstrate a readiness probe. So in addition to, so there are broadly 3 types of probes in Kubernetes. I think there's a readiness, a liveness, and a startup probe. And we provide out-of-the-box monitoring for all 3. So I think what Eric demonstrated was the readiness. Am I ready? Is the pod ready to serve traffic? A liveness is, am I up and running? Right? Am I alive? So if I'm not alive, if the pod is not alive, Kubernetes just restarts the container. And like we discussed earlier, there is a cascading effect of restarted pods. So if you take a Java example, again, the fact that a liveness probe failed could be because of many reasons. It could be because of the application code. It could be because of a JVM memory issue, a leak. It could be a deadlock in the code, or it could be just a badly configured JVM or a badly configured container or the operating system, or there could be a noisy neighbor, right? So you are not the problem. Another pod is causing thrashing or saturation on that node. So EG takes all the signals from all of these, what I said earlier. As you saw, there's an end-to-end correlation that's happening. And obviously, no tool can pinpoint the exact problem. We'll gather all the symptoms, show them in the alarms window, the alert window, and the AI would help as well. But pretty much, you will have a good starting point to find out why that probe is failing. Hope that sort of answers the question.
Yeah, I think so. Really clear. Thanks. So Eric, what is the pricing model on which resources do you license the product?
Yeah. So important question, of course, one that we get a lot. And our licensing model, you could say, is basically based on counting the number of Kubernetes cluster that you will monitor, the number of nodes, and the number of containerized applications. So it's really a predictable model, to call it that, because we don't basically care about the resources that are being used. So no matter if you have a machine that you want to monitor that has a lot of cores or has a lot of gigabyte of memory, we don't look at data ingestion, we don't look at retention times. So it's really a lean model.
Yeah, and with that, we've covered all questions. Thanks for your time and listening. And if you have any questions or you're interested in a trial, let us know. And make sure to reach out with any one of us. Thank you.
Bedankt voor het kijken naar deze video. Wil je meer zien? Abonneer je op ons kanaal en volg ons op LinkedIn.